This
quick
conference
slides.
will now be recorded.
So can the negatives outweigh the positives? Couple of quick slides about Ricardo. Experts in critical and complex railway systems and projects across the world. So let's start with an overhead photograph, and you'll find out why that's relevant to this talk if you listen to the end. So electrification, particularly overhead electrification at high voltage, is generally seen in a positive way. Typical benefits claimed include the simplification and thus reduction of cost of rail vehicles, the local elimination of pollution, especially if the alternative is a diesel-powered vehicle, and a cleaner image. However, there are wider cost and external effects. These are not always fully thought through as an electrification scheme moves from the feasibility stage through design and construction to taking into use and to the operations and maintenance phase. So looking first at implementation issues. Typically, physical implementation requires significant disruption to train services over months, if not years. This can destroy the rail market on the route and thus potentially electrification's own business case. For example, electrification of the Cross-City line in Birmingham required the suspension of evening and weekend services, forcing passengers to use alternative modes of transport. As the electrification works coincided with a recession, those other modes were not crowded, and there was a degree of modal shift away from the railway that took a long time to recover. Although it is now the practice to install signalling assets that are designed to be compatible with future 25 kV overhead electrification, this was not necessarily the case in the past. Therefore, where electrification does not coincide with resignaling, there can be a significant amount of work for the immunization of the existing signalling, including, in particular, changes to track circuits. The design life of a bridge is typically of the order of 100 to 120 years. Some forms of bridge, such as brick and masonry arches, can, if the foundations are not disturbed, last much longer. When electrification requires the reconstruction of bridges, it has to be recognized that there is a cost in environmental terms of destroying bridges with decades of remaining life. There does seem to be some potential for a form of practice. The London Brighton and South Coast Railway electrified much of its suburban service in the early years of the 20th century, using a 6.7 kilovolt AC overhead system. To avoid reconstructing certain bridges, there were dead lengths of contact wire. This concept is now being promoted as an innovation, although recent experience seems limited. The trains could deal with quite a long dead section. Up to 60 metres is recorded in Hamilton Ellis's The London Brighton and South Coast Railway. Great Western electrification introduced the concept of combining surge arresters and insulated coatings at the Cardiff intersection bridges, avoiding difficult reconstructions. It will be interesting to see how the coatings perform over the years and how often they have to be refreshed. In that context, there is also a need to ensure that the insulating coating or an equivalent remains on the market. So the images of the GLS coating on the left and the Network Rail accepted surge arrestor are taken from material supplied to Ricardo certification, the assessment body. In fact, I was the assessor who had to review the risk assessment that supported the submission, and that was in support of the Network Rail safety justification. So one alternative to bridge reconstruction is track lowering. where, as is often the case with older bridges, the abutment design relies on the presence of passive earth pressure on the lower face of the abutment for stability, the abutment needs to be underpinned. Unfortunately, there is usually also a need to modify the drainage to avoid the creation of a sump. And track lowering adversely affects the track top profile. And on a higher speed line, there is a need for long run-ins and run-outs to comply with the relevant design parameters and to avoid the creation of a permanent speed restriction. This work inevitably requires possessions longer than the maintenance white periods and, not infrequently, temporary speed restrictions whilst the new track profile is created. As with bridges, there is a cost in environmental terms of changing an existing asset configuration with remaining life and generating ballast and track waste. A second alternative to bridge reconstruction is the installation of a track slab, common where there is a tunnel or a succession of bridges. It is rare that construction of slab track does not require a blockade of the track, for a period more likely to be measured in weeks rather than days. In addition, the construction of transitions between track slabs and ballasted track can be problematic in terms of quality control. Electrification also requires a significant earthing and bonding exercise. It is necessary to consider all existing metal structures, including footbridges, line-side fences, station furniture, etc. At metal bridges, the risk of dangerous touch potentials must be eliminated. There is an increased need for on-site work. Whilst rolling stock can be maintained offline in warm, covered accommodation, protected from the weather, with plant, tools, support, etc. to hand, electrification assets have to be maintained at height, often at night and in the pouring rain, and in winter in the freezing cold. This makes achieving quality difficult and introduces additional safety risks. If problems arise, support is remote. Although train-mounted remote inspection techniques are now quite sophisticated, there remains a need for some physical inspection, and so the same issues arise as for maintenance. The need to use access platforms, whether train or plant-based, means that there is a need for track access and, of course, for isolations of the electrification system. And this leads on to the difficulties for other assets. Where the presence of electrification now means that track access for work also requires an electrical isolation, there is a significant reduction in available work time. It is not the isolation itself that takes the time. This is merely a matter of switching. It is the need to secure against re-energization and to apply earths. There is a common misconception that the requirement to apply earths during an isolation is to deal with the possible presence of induced voltages due to adjacent live electrical equipment. While it is true that such voltages do occur and are sometimes remarkably high in the thousands of volts, this is not the primary reason for the application of earths. The primary function of the earths is to provide the security of the isolation from inadvertent re-energization required by Regulation 13 of the Electricity at Work Regulations, Statutory Instrument 1989-635. Until the earths are applied, the overhead electrification equipment can only be said to have been switched off in compliance with Regulation 12. The requirements of both Regulation 12 and Regulation 13 are absolute. Use of risk assessments to support an as low as reasonably practicable argument is not permitted. Unless the switched off equipment is secured against inadvertent re-energization, it cannot be said to be isolated, and it would not be appropriate to issue any permit to work. It should be noted that the regulations have not been made as a result of European safety legislation, and that there are different electrical safety requirements in different European countries. Permanent earths have been tried. They were used on the original British West Coast Main Line electrification in the 1960s. However, many earths were used very rarely and became unreliable due to dirt, corrosion, etc. It was found that a significant ongoing effort was required to ensure that they were 100% effective. Hence, the current practice of designated points to facilitate earth attachments. I've had practical experience of these issues. As a maintenance manager in the Birmingham area, I could contrast work on the electrified Rugby, Birmingham, Stafford lines with the non-electrified Derby, Birmingham, Bristol lines. During my work as implementation strategist for West Coast route modernisation, I started to review the post-modernisation inspection and maintenance workload for each asset and assessed whether the track access was sufficient. It was a factor in my work for High Speed 1's Control Period 2 track access charge submission. I had to explain to the ORR regulatory hearing the relationship of cost, available work time, and quality for the inspection of maintenance work. Hours of operation on HS1 are much longer than on the French Ligne Grande Vitesse, as the Javelin service starts early and finishes late, and there is some limited freight traffic. There is also no daytime white period. Here's a worked example. It's far from extreme. So if we assume that the no trains period is 4 hours, then before anything can happen, you have to isolate and apply earths. And I've said half an hour, but it's probably longer. In fact, it's almost invariably longer. You've still then got to mobilize on site after the permit, and we'll say half an hour. So you've only got 2 hours before you can clear the site and surrender the permit, and then again removing the earth's re-energization process. Half an hour, possibly longer. And longer sites require earths at least every 400 meters. So you've got 2 hours work after a 4-hour white period. If we take out the electrification, you've still got the 4 hours with no trains, but now you've got the half-hour mobilization and the clearing site half an hour. So you've now got 3 hours. And in a very tight white period, that increases the effective time by 50%. It's also an issue, but perhaps less so, for conductor rail electrification. The electricity at work regulations led to much greater use of short-circuiting straps, but these are easier to attach than OLE earths. Many OLE routes are mixed traffic and without electrified diversion routes. Conductor rail track is often on commuter routes or multi-track main lines, many with electrified diversions. Extensions to white periods are easier to agree. As noted earlier, the overhead electrification asset requires track access for inspection and maintenance activities. This means that for those wishing to carry out maintenance and inspection work on other assets, including tracks, signalling and structures, there is an increased competition for track access to carry out that work. Where a line is electrified on the overhead system, track must be maintained to tighter tolerances. This is particularly important for cross-level, as the effects at track level are typically multiplied 3 times at contact wire level. Care must also be taken over the maintenance of top to avoid affecting contact wire gradients and of alignment. On straight track, the contact wire is arranged in a zigzag pattern to minimize the risk of wearing a groove in the pantograph contact strip. On curves, the contact wire takes the form of a series of straights. In both situations, the track alignment must be managed to ensure that the pantograph remains in contact with the contact wire. This need to maintain to higher tolerances means that track access for maintenance is required more frequently than would otherwise have been the case. However, on high-speed lines, the need for precise management of track cross-level, top and alignment usually means that the presence of overhead electrification is less of an issue. As the rails are used as the initial return from the traction current, great care must be taken when carrying out work not to interfere with the path. The red bonds, which are part of the link between the rails and the return conductors, can, in some fault conditions, be live at 25,000 volts. Extension of electrification increases the presence of bonds. This is in contrast to signalling, where the increasing use of axle counters reduces the number of bonds attached to the rails. The need to maintain 3.5 meter clearances to live overhead line electrification equipment, not just the contact wire, complicates the maintenance and cleaning of station structures, particularly platform canopies. Where the introduction of overhead electrification has meant the installation of sections of slab track, e.g. through tunnels or under a succession of bridges, there is a need for transitions between the track slabs and the ballasted track at either end. Because of the varying degree of rigid support, the transition is difficult to maintain, with additional attention and thus requirement for track access having to be paid to cross-level and top. There is a need for additional vegetation management, particularly where there is a risk of tree branch contact with unsheathed return conductors, requiring further additional track access and isolations. We're also considering a single point of failure, and the pertinence of this will become clear right at the end of this presentation. Overhead electrification introduces a new failure mechanism for the railway in that a loss of power immobilizes the train, whatever the state of non-electrification engineering assets. Accordingly, many suggestions for mitigating electrification failure consider how power can be brought to the train. However, a failure of the mechanical electrification system is unlike the other engineering assets. There is essentially a single point of failure which cannot readily be mitigated to allow trains to pass and clear the line. Concern about this type of failure with a transmitted power system goes back to the earliest days of the railways and the debate amongst the proposers of the Liverpool and Manchester Railway about whether cable haulage or locomotive haulage was the way forward. Similar discussions of principle surrounded the atmospheric system. In many situations, a failure of the catenary system or a headspan means that the clearance required to pass trains is infringed. This affects non-electrically powered trains as much as electrically powered trains, although the non-electrically powered do have hotel power whilst waiting for the situation to be resolved. Objects blown onto the railway obviously cause the suspension of train services whilst they are removed. However, where the line is electrified, there is an additional likelihood that, for example, plastic sheets will be caught, and then an additional problem in that the removal requires the electrification to be isolated and made safe before the object can be removed, increasing the time required significantly. Let's compare that with managed degradation. In contrast, failures of other assets are often amenable to mitigation, which will allow the movement of self-propelled trains, so reducing the disruption to passengers and freight customers. If a broken rail is reported, then processes are in place, for example, clamping, which will, in many situations, allow trains to be passed. This may possibly mean the train moving at walking pace and with inspection required after every movement over the break, but at least movement is possible. Similarly, a developing track cross-level twist or a subsidence can be dealt with by packing the track between trains and, as necessary, allowing movements at walking pace. However, this may not be possible where there is overhead electrification because of the need to maintain the pantograph to contact wire interface within tolerance. Where the track has buckled, it is possible, if space is available, to slew the track to form reverse curves that will allow movements at slow speed. However, again, this may not be possible where there is overhead electrification because of the need to maintain the pantograph to contact wire interface within tolerance. Where an underbridge has been struck by a road vehicle, processes are in place which can, subject to conditions, often allow movement at walking pace pending structural examination. Points can fail for many reasons, but it is normally possible for them to be operated manually by staff on site in accordance with the signaler's direction to permit trains to pass. When the control system or signaling system fails, various mitigation measures can be introduced depending on the nature of the failure. Movements may be authorized through a section at caution, or station-to-station working may be introduced. If the failure is likely to remain for an extended period, ticket working may be practicable. If the signalling fails on a single line, pilot working is introduced, in which a clearly identified person effectively acts as a human staff. So, in conclusion to this part of the talk, whilst the introduction of overhead electrification may have its benefits for the operation of the system and for its users, it must never be forgotten that there are significant operational and asset management disbenefits, and these must be carefully considered as part of the commercial analysis of electrification proposals. So thinking about environmental alternatives, hydrogen engines, which can use modified diesel engines, I'll talk about those on the next slide. Hydrogen fuel cells have some similar issues. Batteries, liquid air, which has barely been touched, and then there's a liquefied natural gas as an interim, which again I'll talk about in a second. So, hydrogen. Ricardo, and this is including our automotive and energy colleagues, we carried out some work on hydrogen for freight early in 2021. Some of you may recognize the photograph on the left. It's a brake tender. We thought, given that hydrogen is not a high energy fuel, unlike diesel, which is, we thought that something the size of a brake tender may be the way you would have to go. The advantage of brake tender is the driver can see over it and you actually don't have a problem apart from the length. Unfortunately, the calculations showed that the tank wagon on the right was nowhere near enough for the current ranges achieved by diesel locos. And obviously you've got all sorts of problems if you've got at least one tank wagon of that size with the diesel locomotive, or even though it's powered by hydrogen. If we look at the liquefied natural gas, the left-hand photo is Florida East Coast, and there the liquefied natural gas tank sits between two locos. Their maximum range is 300 miles, so the range is not particularly an issue. The locomotive on the right is a Russian loco, with the loco on the left and its hydrogen tank on the right. The problem with both of them is the increased length affecting run rounds and the like. This is Felixstowe, one of the major intermodal ports and terminals. You can see on the right-hand photograph the loading tracks, and to avoid a long ladder with all the sidings and a head shunt, the way that locomotives are run round is to use a traverser. This is clearer on the left-hand photograph. You can see the traverser is just about the length of a diesel loco. So this means that at every location where you run round trains, you would have to look at the head shunts, look at the traversers, and work out how to extend them without reducing the standage, given we want to try to have trains up to the 750-metre length if we possibly can. There is a non-environmental alternative. Everybody may well remember the problems with Blackpool and the electrification to get there and how many years that took. Well, following the electrification to Blackpool, I had to travel up there a couple of times. I suspected from my ticket booking that it was a Voyager and not a Pendolino. And sure enough, on the 10th of August 2019, I arrived on the platform at Euston. It's a Voyager, and we're going to be travelling in diesel all the way up the old West Coast electrified as far as Preston, then the new electrified railway all the way to Blackpool, 226 miles diesel. And then it happened again on the 16th of November 2019. Again, you know from your ticket it's going to be a diesel, and it's the Voyager. Does make you wonder what the point of electrifying it is. So, coming back to the start picture, it's Windsor Castle, and this is Windsor Castle as well. And there's the prompt for this presentation, and in fact, the prompt for the anonymized article that was in the PWI Journal about 3 or 4 years ago, was coming to a stand on a high-speed train from Bristol at 5:05 at Slough. And the conductor came onto the public address and announced that because of problems with the overhead wires between Heathrow and Paddington, we were going to have to sit there for 20 minutes. He said, but I'm opening the doors so you can use the platforms, wander up and down, do what you want. 20 minutes later, he came back on and said, sorry, instead of getting into Paddington 20 minutes later, you're not going to be in Paddington now until 8 o'clock. He then started to say, however, Southwest trains are passing, and I, together with a considerable proportion of the trains, stampeded across the bridge at Slough. The 17:30 shuttle to Windsor left crush loaded, and then there was a spin out from the train out onto the road, and these castle walls saw a crocodile jog trotting down the slope, round the corner and across into Windsor and Eton Riverside. So that's the relevance of that to this talk. It's the jog trot along there that prompted the thinking about the issues. So thank you. I'll stop sharing. There we go. So, Andy, how are we doing for questions?
Right, so there aren't any questions in the chat at the moment, John. Thanks very much for that very thought-provoking talk. There's one particular question that I do want to ask you, but I'm going to save it for the end because I'm sure you'll have been asked it before. But in terms of those new potential solutions that you spent a little bit of time on at the end of the presentation there, which of those do you think has the most promise, and why do you think that?
It depends on what you're looking at. If you're looking at fairly short branch lines or that sort of thing, then the battery has potential. It's it's not particularly new technology, and as rapid charging for batteries becomes more and more available, using battery trains to extend existing overhead line systems is of some potential. Going back to something that was in the paper and that had some discussion on LinkedIn after Network Rail put out a publicity statement about it, it'll be interesting to see how the coating used at the Cardiff intersection bridges goes on. I would say that that is a coating in millimeters, not microns. It's a lot thicker than a paint would be, although it's applied in the same way of a paint. And surge arresters again. So there's quite a bit more to do. And it does require isolation fairly regularly, unclear at this stage, but it's going to be monitored initially. And the suppliers of the coating have a device for measuring its thickness so they know when it's to be applied. So that may give more potential, as may be the use of dead sections. Apparently people are worried about drawing currents. So if that can be avoided, it clearly wasn't felt to be an issue 100 years ago, but things of course change. Hydrogen's interesting because with road vehicles, providing the extra space for the hydrogen is less of a problem. And therefore, hydrogen buses, hydrogen refuse collection lorries, that sort of thing are very likely possibilities. Hydrogen on trains takes up space. What you might find is the trains, for example, the new Anglia trains, it may be that you can modify that diesel pod and include that as fueling, but otherwise you're losing a lot of space on the train for the hydrogen. I'm not sure about the liquefied natural gas because that's simply taking another carbon-based product. It's just that as an interim, it might be better than diesel. It might be a cleaner fuel for that. So at the moment, hydrogen has possibilities for lighter trains. The batteries have possibilities for lighter trains. The big issue is what you do with heavy haul and with the long intermodal trains, and making sure the diesels have a replacement that's actually usable without having something that's much longer and requires an awful lot of infrastructure work. Because as people will know, the Class 66 at the moment goes anywhere. They're working all sorts of trains. And once you start down the road, you need to do all the work in advance. So liquid air, we at Ricardo started to look at, but it didn't seem to get very far. So it's going to be, I think, horses for courses. Obviously, infill electrification would help for freight, but one of the problems when you start with freight is you then run into the white period question and trying to ensure that you have enough time to do things. Whether Robel and Matisa maintenance trains are going to be the help, we shall see. They're certainly well regarded where, as you've probably found from your contacts, they're well regarded where they're in use.
Definitely. Questions are starting to flood in. So first off, we've got a question from Stuart Corrie, and I wonder, as we're quite a small group, perhaps I could invite you, Stuart, to take yourself off mic and ask in person. Thank you.
Do you have to unmic him? Mic broken at the moment.
I think he can unmute himself.
I was just posting mic broken at the moment, so you're going to have to.
Oh, right, there we go. I'm going to ask on his behalf then. Thank you, Stuart. You were talking about getting out of trouble on non-electrified railways. And Stuart asks, is packing the track between trains at all realistic on at least the pre-COVID railway with the frequencies that were normal practice?
Again, it depends
What's
very
your
much
view
on
that?
it depends very much where you are and what the situation is. If you've got trapped trains that you want to take out and you've got space for people to stand safely, then effectively you're taking a possession between trains, or in old speak a T2 between trains, to do the packing between trains. It's not going to be one of universal. It's just that it was something and still is in places something that is doable. And it's like all those mitigations, it's designed as a get you home. If you've got a train that's in an awkward place and you're going to have to think about it, you know, is it this or evacuation of people onto the track because there's nothing else you can do with the train, then that's the sort of situation I was envisaging. The problem is if the wires are down, you've got no way of passing. With the other options, you might be able to do something. So no, it is definitely not something that's a universal panacea, but it's something that may be available in situations, particularly if you can't go back, you know, or you're a long way from going to somewhere where you can take people off trains.
Yes, thank you. Next question is from Paul Ebbott, who's got a question about the other sort of electrification. Paul, if you're able to come off mic.
Yeah, okay. Hi, thanks for that, Andy. Thanks very much, John. I'm a bit sort of disillusioned with overhead electrification now. So the question is just, are we okay talking about Conrails here tonight?
Yeah,
or is that a bit naughty to even think about it nowadays? Sorry.
No. Remember, I'm a former Southern Region person, and
Good.
I was an ORR person, or HMRI person, dealing with the Southern Region. And as you know, I've had quite a lot of experience in the last 20 years with London Underground. So you talk away about conductor rail.
So my talk, to as you can gather, I can't say I'm fond of Conrails, but that worked fine in certain, for me, in this sort of metro arrangement. So I think to myself, all these barriers that you've touched on, and I have encountered some of the overhead line interfaces, some projects I've had, you think to yourself, well, listening to Nick Millington earlier this week about feet off ballast and all this sort of high-tech yellow trains and investigating plain line pattern recognition, and now one for S&C they're talking about, that we are going to keep people away from the railway. So why don't we actually sort of think, well, if we're going to keep people away from the railway, then we don't need to worry about the hazards of exposed Conrails. And maybe that's the principle behind the DLR when it was accepted into use. I was on that project and I was shocked that we were actually got permission to put in a brand new Conrail railway in the UK. And so maybe we shouldn't be so scared of it. That's the what I'm saying. If we are going to keep people off the railway and we're going to have controlled maintenance access periods. So,
well, I mean, one thing is the DLR, of course, has a sheath over it, so it's not quite the same hazard to inadvertent people, and that's one of the problems that currently ORR seems to be worried about, trespassers and people like that with it. But yeah, it's quite interesting that they have that approach to the 750 volt rail, where from my flat, I can see 750 volt cables, bare cables above the street with people walking about. And there seems to be less concern about a 750 volt cable above your head than one behind a security fence. So I think there's a little bit of inconsistency there. You know, we've got the tramways, and it's Croydon I'm talking about, just an example, but you know, 750 volt above street with open access is, you know, is to my mind at least as big a problem as 750 volt rail particularly with modern fencing. I mean, obviously you've got idiots jumping down off platforms, but then they're at risk from the train as well. So yeah, it's an interesting one. I mean, the other advantage, of course, with the London Underground system is you don't have to worry that much about the returns, because you balance the voltages and you've got no issues with stray currents that you get with tramway overhead, because again you've got a dedicated return.
Indeed, thanks.
That question was backed up by Simon Hardy as well, who said, "Great question, Paul." Simon, is there anything else you want to follow up on that subject?
Hi, Andy. Hi, everybody. Not really. Yeah, I was with the OR for a while, as some of you all know, and I was aware of their position. But having worked on the third rail for many years and recognised it's dangerous, now we're into sort of the modern times of protecting the environment. It's just, I think it's something which we need to question again. Obviously, the third rail has its problems, like overhead has its problems, but yeah, it's looking for solutions.
Yes, I think I saw something go up that it was pointed out that there are issues with high output plants, and obviously the tampers have to lose tines and that sort of thing. You know, so it's not a panacea, but I regret to say that it was some of my West Coast route modernisation work that led to the DFT worrying about Ashford Hastings and the Uckfield lines in the 90s, because I did a lot of work on disruption costs for West Coast route modernisation. Which of course, West Coast being a 24-hour railway and used by everybody and their dog, doing work on West Coast and looking at the Schedule 4 and Schedule 8 rates was quite frightening. And I understand the DFT looked at that when read across in the 90s when the old Hastings and Oxted units were being replaced, and sort of priced in electrification with those sorts of disruptions, ignoring the fact that the Uckfield line didn't have a Sunday service at that stage, and the Ashford Hastings line had a single shift Sunday in the summer. So the disruption costs became a major barrier to electrification, because they took my very extreme West Coast ones, you know, which is a 24/7 railway, busier in places overnight, particularly like over Shap, busier actually overnight than during the day. And that was used in the modelling, which was unfortunate, but there we go.
Thank you, John. Can I ask Phil Ransom to ask his question? I think he's interested in a bit more information on insulated coatings and stuff like that.
I mean, more general than that, perhaps I'll put that in as the start of a 10. But yeah, thanks, John. What a fantastic presentation, you know, covering the wide-ranging aspects of electrification. But the thing that's kind of challenging my mind is, you know, somehow we've got to create a carbon-free or carbon-neutral railway. The only proven technology we've got for traction, really, you know, that's potentially carbon neutral, albeit I'll take your point about point of source and all that sort of thing. But the only option we've really got is electrification at the moment. We've got these alternative fuels and alternative solutions, which are fascinating. But the other big challenge is the cost of electrification. You know, every time we try to electrify a route, the costs seem to spiral 2 or 3 times. And yeah, it becomes unaffordable, and the whole thing stops again because everybody sucks their thumb and says we can't afford electrification, and then we go through another cycle and we start again. I'm intrigued by these sort of technologies of, you know, like the insulated coatings, which, you know, it'll allow you to get wires under Cardiff intersection bridge without lowering the track and without reconstructing bridges and things. So, you know, potentially that brings the initial cost down. An interesting point you make about the ongoing inspection and maintenance of those coatings. I've wondered myself about how long they were going to last and when you're going to go out there and paint them again. So
well,
I'm not really asking a question. I'm just regurging your presentation and coming back with all those issues. But yeah, the real challenge is we've got to find cheaper ways of electrifying the railway, I think, with less intervention, but some really interesting points about the operations and the recovery issues. Yeah.
Yeah, I think that you made an interesting point there, Phil, because the danger is people see it as a paint and not as a surface coating. And whilst it's, you know, it's sprayed on like, you know, modern paints are, it's remembering that it's there for a particular purpose. It's there as an insulating coating. It's not just a paint. And it's getting people to think through that. You can imagine how somebody in a value engineering exercise will say, well, let's just paint it and things like that. So it does need care. In this particular location with the river going under the railway at a place where you've got an overbridge over the railway with railway on it. You know, it was a place for lateral thinking. But the other thing to think about is, again, given Great Western electrification, is just when you compare the kit that was put up there. And going up the West Coast on Saturday, I was just looking at, you know, even the original 60s south of Crewe was nowhere near like that. And they were putting it higher to allow steam engines under and all sorts of things, you know, the Stafford northwards up to Weaver. And then, you know, even looking at the, you know, the much maligned North, you know, Manchester Blackpool electrification, you know, it's nowhere near what Great Western had. You know, and that's one of the problems if you over-engineer. To, you know, to for something that you know, there was a you know, it's just that, you know, that just simply makes the costs disappear into the stratosphere. And then
well, I agree fully about Great Western electrification. I don't know if we've got any overhead line engineers on the call or on the day, but I can't understand the size of those structures. You could tie a super tanker to most of them, and without any problem. I'm just gobsmacked by the amount of steel they've used, but there you go. I'm sure they knew what they were doing, perhaps.
Yeah, no, it's just interesting with comparing it with some contemporary ones that, but there we go. So, yeah, I mean, cost is an important issue, but you see, then there's the other knock-on cost that has to be thought about, which is the time it takes to prevent re-energization and then to release everything, and the effect it has on the white period and on the costs of doing work. And this came out in the work I did for High Speed 1. You know, because the question at the regulatory hearing is, why are our track access costs so high? And the answer is because you're having to double up. You know, it may be that you could do the work in an 8-hour shift, but you don't have 8 hours. So you have to have 2 teams doing it in 4 hours. And the problem then comes is if you start having less time because of the time at either end, that when you have to do things like change switches, you know, you're actually not having to use white periods, you're having to actually blow your weekends. And if you've only got a limited number of weekend facilities, you know, you're then into emergencies for changing switches.
No, really.
It's becoming a problem. Is actually resourcing it up, because you need to multiply, you know, you're all right provided the work can be done by multiple teams. You just have to bite the bullet and have twice as many teams. It's actually the work involving welding and things like that you know, then you're starting to say, well, can we actually fit it in? You know, and there might even be an argument for you know, switches of going back to having tight joints on the basis that you're not having to spend the time doing welding if that's all you can do in the white periods, if you have to do a change of switches.
Thanks, John. Martin Cresswell, you've asked a question about technology to help with isolations.
And Martin asked it himself. He's
Yes.
I can try.
There you go.
Go on,
Yeah,
Martin.
yeah, success.
Yeah, well, really just seeing if there's been any progress in reducing the isolation times by the introduction of technology, remote earthing, that could reduce the time taken to earth out the overheads.
I mean, one of the problems is that, as I say, the original West Coast had automatic or remote earthings, but they found it was a major job to keep it in a workable condition, which is why they went over originally to lassoing the wires, and now at least with designated earth points, you don't have the huge things that straggle from the catenary down to the rail. It's interesting that other European countries do have less. In connection with a project I'm working on at the moment, I've done a trawl of my European colleagues, and they've come back to say that ADIF in Spain does the mixed-use railway under Madrid in 15 to 30 minutes, and they're very anxious to keep the possession and isolations time down to 15 to 30 minutes either end, because they have a very limited white period, because it's used by everything from the high-speed trains doing their run through north to south, and expresses and commuter rail and everything. And we've actually now got a copy of the ADIF equivalent of the Green Book, the 25 kV working instructions. The trouble is that even in the message from ADIF to our Spanish colleagues to us, we can see that there has been some curious translation. And so, having got the ADIF document in Spanish, we're now trying to work out how to make sure we get a technical translation and not a translator who's well up on the work of Cervantes or whatever. Which far too many translators tend to be. They tend to be literature people. So that's going to be interesting. We've only had it a few days to find out why they think, they think they do, because the ADIF person came back to say that this was critical to them, but we're taking so much longer, even with modern technology. I know one system that's looking at having testers and earthers as part of work groups, so that you don't have to have people traipsing around the countryside to do the earthing for work groups. Now that will work fine with embedded in-house people who you can train up, but much more of a problem with contractor staff who may be using skills very rarely.
Thanks, John. Phil, you've got a point to follow up on that?
Yeah, I was just minded. I can remember development, and it's going to be more than 10 years ago, a concept, and I think it was prototype for sort of some kind of automatic bonding around tamping machines, where the tamper was fitted with I think a pantograph. I don't think it was a third rail system, although my memory might be playing tricks on me. It might have been a third rail system, but in essence, the machine arrived on site and it bonded itself out while it was working, which always struck me as a good idea. So perhaps this idea, if you add that to this sort of, was it the Robel sort of factory on wheels type systems? Perhaps you could get people on and off track much quicker if you could actually, bond out at the point of work.
Well, the Robel means you don't need to worry because you're inside. In fact, High Speed 1 has got vehicles with earthing pantographs, and they do have that where they have, it's a double unit, and the pantographs do provide earthing between them.
Begs the question, why aren't they doing it everywhere else on the electric railway then? Because it must be losing massive time.
Yeah, it depends on what you're doing and what you're using it for, but it is available for work you can do from the train. That's the point. So, you know, if you're using the train as going upwards, it has value. But if you're doing stuff at a, you know, to the side or to lower levels, it may be, you know, if the train deck may not be the appropriate place to be working from. So yeah, the idea. In fact, it's a very old idea that tramways had it as well, going right back into the glory days of tram in the Edwardian era. They used to use techniques like that. So it's not. It's like, you know, the dead section under bridges. You know, we're revisiting some of these ideas, and I think the dead section under bridges one. I'm not sure quite what the issue is with it. To be fair to Network Rail, they've been doing a lot of work over the last 6 or 7 years on improving the time to do it, but it does seem to be a very slow process of getting something that's approvable into the system, because I understand it's not stuck in the system, it's still demonstrating it's doable, if you like. So then there's the taking it through the system. Because the project I'm working on is sort of looking sideways at what Network Rail's up to because of the problems it has.
Fascinating. Yeah. Another question from Paul Ebbett.
Yeah, hi. Again, thanks, John. Straying from railways, I've got a couple of young lads who keep nagging me about now the legacy that our generation is leaving them to do clear up. But when I look at the sort of statistics and stuff that Rachel Skinner has said to the ICE in the presidential address, railways is sort of minuscule impact compared to highways. And I just think to myself, I don't know what the highways are doing, but how the devil do you help the large freight stuff on the highways? And now there's some lessons. I mean, there's some of the points you make on the sort of challenges, and other highway people are aware of this and they don't want to be going down some of the routes. I don't know what they're doing. But are we sharing knowledge, rail industry, highways industry, and this sort of thing? Does anyone know?
We are in Ricardo. Because we've got a big automotive and people dealing with, as I say, you know, it was a joint exercise when we looked at hydrogen for freight locos, and that spun out of work that my automotive colleagues are doing with hydrogen buses and hydrogen goods vehicles. And the way that they're working is with local buses where you have you know, all working out of a depot, and with some of the councils in the south of England working the council's vehicles, particularly the refuse lorries and things like that. So larger vehicles, but with smaller range, working out of the depots as well. So on that side of it, that's developing, and the fact that you can use hydrogen in a diesel engine, provided you can find space to put the tank, and between the tractor and the trailer seems to be favourite at the moment, you know, you can do that. You know, that's the sort of route that's going down for that. So that's again, the problem is range. So, you know, it works fine for the smaller ranges. It's down to the fact that you need an awful lot more hydrogen than you do diesel.
And is hydrogen accessible? Is it going to be available in the quantities?
That's an interesting question, because, you know, it's all very well going to green electricity for everything else, but you'll need an awful lot, a lot of that green electricity to create the hydrogen. It's a question of, it's coming back to generation, but then you'll need the green electricity if you're electrifying the railways as well. Yeah, and power supply has become an issue. So I don't know whether anybody's seen this month's Modern Railways, where the distribution companies complaining about strengthening at Grantham and Retford on the East Coast Main Line to provide the enhanced East Coast service. So that's, you know, another problem is green electricity, whether you do it via hydrogen or you do it directly. So you know, it's you know, it's an issue because you've then got to you know, sort out where you're getting your electricity from to do either hydrogen or batteries or direct. You know, it's the electricity that's going to be the ultimate question.
Thanks, John.
I saw somebody flashed up about 25 kV over the motorways. Is it 25 kV or is it 750? Because it's no different to a trolley bus, and that goes back to trams. And I think light rail is sometimes being suggested where you'd actually be better off with a trolley bus, then you can dodge around the traffic. And some years ago, when we were looking at West London and we were looking at the implications of, you know, places like Ealing and Acton, and trying to work out what on earth you would do with the shops which are all frontage served, and trying to create lanes, something like a trolley bus, which can maneuver within the traffic, struck us as probably a better solution than a guided transport system, because you get the same benefits, and it's easy enough to fit a trolley bus with batteries, so that if you need to do something, you can divert around the streets as the way the Nancy system does. Although it's a guided trolley bus, they've actually got batteries, and when there's works going on, they simply go down the parallel road. You know, and that's a lot cheaper than putting track in the street. So if it's 750 volts, it's no different. But I don't know what the German system's using. There doesn't seem to be any good reason for it to be 25 kV because you don't have the power needs. Yeah, I mean, you can do enough amps for a couple of lorries easily with a 750 volt DC.
It's a fascinating and wide-ranging discussion. Would anybody else like to ask John a question as we move towards the close of our meeting?
One thing I would say, Andy, is that what will go up on the website, what I'll send off to Sarah, is actually my prompt rather than what you all saw.
Oh, thank you very much.
Yeah, so you get a lot. You get a lot more.
Archive.
Yeah,
Yes.
you get a lot more. But then, you know, people who've heard my previous ones will know that that's what I tend to do. So, yeah, that means that it's there for, you know, future reference.
Great stuff. If I can outrageously use guest chairperson's privilege, then in that case, and particularly bearing in mind some of the questions that have been about what we're leaving for our youngsters, and I'm sure you've got plenty of get out room in your title, but what would you say in conclusion as your own view of whether the negatives outweigh the positives for either overhead electrification or electrification in general? What's your own personal view?
I think it's horses for courses, says he, dodging the question back. The point is that you know, if you've got the right environment and you build in from the start a maintenance system that you know is achievable, you don't anticipate magic mushroom solutions for taking isolation and earthing. You just accept that, you know, this is what the law requires. And then you look at it on that basis, then you've obviously got benefits, because you're not, you know, high-speed trains probably push diesels as far as they could for high speed. So if you're going to high-speed lines, you obviously need something like this. You know, whether it's, you know, if you go, because the current guided transport system gives the advantage of projecting the trains here, there, and everywhere. I mean, it's noticeable, for example, in France, that they quite happily send their TGVs off the high-speed system to run beyond Marseille to Toulon, then off the main line to run down the branch to Hyères, which acts as a railhead right along the coast, Saint-Tropez. And you can't do that easily with maglev or hyperloop or anything else. It's purely city centre to city centre. So you've then got to think about how you do that. Interestingly, in France, they had no problems about electrifying down the branch to Hyères for basically an hourly service and the odd TGV. So, you know, they've obviously got a different cost benefit model. But then when you look at some of the branch lines, you then start to think about, well, you know, why are we paying for all this infrastructure for a class 153 once, you know, sort of 4 to 5 times a day? Is this really a good use of actually, you know, the country's money? And when you look at some of the reopening your railway and you look at what it's doing and you think, well, what is the justification? You know, we're all infrastructure engineers. We know how much it costs to maintain our infrastructure. You've got to put it where you need the specialists. You know, it really justifies having a specialised infrastructure. And a one-coach train 5 times a day doesn't really seem to justify specialist infrastructure. But there we go. You know, it's going back to Stuart Joy's The Train That Ran Away. You know, he said that if the loadings only justify a bus, use a bus and save yourself on the infrastructure costs.
Thanks very much indeed, John. And ending your responses with a quotation just serves to emphasise how sort of how broad your interests and attention to detail are. So thank you very much indeed for a fascinating talk, which prompted a really wide-ranging discussion. And we haven't even strayed into the whole business of autonomous vehicles, which is probably out of bounds for the PWI anyway, but certainly not for the after meeting discussions that Colin talked about earlier that we hope to return to later in the year or maybe early next year. So yeah. I wonder if I could ask this small but elite band of PWI members to come off mute and give John a well-deserved round of applause for that presentation. Thank you very much, John.
Thank you.
Well done, thank you, John.
It'll be repeated at the London section later in the session. At the moment, it's quite late in the session, but it's there if anybody wants to catch it again. Paul, you'll probably finish up catching it again. Okay.